Alright, now that you've learned about law of sines, it's time to do law of cosines. So we're going to start off with triangle ABC, and we're going to label a height h. And the line segment AB is going to be split up by point D into x and c minus x. Now we're going to do Pythagorean theorem, and we're going to do x squared plus h squared equals b squared. And we can also see that cosine A would equal x over b. Now solving for x, we get that x equals b cosine A. This will be important for later on. And remember, this was from triangle ADC. Now looking at the bigger triangle, triangle BDC, well, it's not bigger, but whatever. We can see that c minus x squared plus h squared equals a squared, right? And you multiply that out, and what we're going to get is that a squared equals c squared minus 2cx plus x squared plus h squared. Now, if you use this formula in tandem with the other two, what you're going to see is basically the law of cosines, where a squared equals c squared minus 2cb cosine A plus b squared, right? But we write that in a better way so that it looks better and it's easier to understand. A squared equals b squared plus c squared minus 2bc cosine A. There you go. Now, what we also have, this is law of cosines part 2 basically. And this time, what we're going to have is we're going to have an obtuse triangle, triangle ABC, same as normal. And what we're going to do is we're going to make a new triangle on the left side of A. We're going to label the vertical component x and the horizontal component h. And we're going to do Pythagorean theorem, where x squared plus h squared equals b squared, right? And then we're going to do, instead of cosine A, we're going to do cosine 180 minus a, which is equal to negative cosine A, to get that negative cosine A equals x over b, right? This is very familiar, it should be. And solving for x, we get that x equals negative b cosine A. Now what we're going to do is we're going to look at triangle BDC. Oh yeah, I forgot to label, but there should be a point D. We're going to do triangle BDC, and we're going to see that c plus x squared plus h squared equals a squared. I'm labeling it right now, don't worry. And what we're going to do is we're going to a squared, we're just going to rewrite it. A squared equals c squared plus 2cx plus x squared plus h squared, right? And once you do the math and you simplify, you should get the same result. A squared equals b squared plus c squared minus 2bc cosine A. Alright, so now it's time to use what you just learned. In this question, we have a pilot who heads out from the airport at a heading of 20 degrees. What this means is that you look north and you go 20 degrees from that in a clockwise direction. He heads out at 200 miles per hour for 1 hour, so the distance is just 200 miles. And he then changes course at 9 a.m. to a heading of 40 degrees, so you just do the same thing as before, but with 40 degrees. The question stops at 9:30, so it's just going to be 100 miles. And let me draw the triangle. Actually, let me redraw that so that it's a bit easier to see. But what you should notice is that we have a triangle with two sides and an angle, and so we can use the law of cosines. We know that angle C is 160, and let me just explain why. That's because we have the 20 degree from the 20 degree heading, we have 90 degrees because of the right angle, and 50 from the 40 degree heading. Hold on. I think I'm missing my triangle. Let me actually just get rid of that. But basically, now all we do is we do law of cosines. So we have 160, 200, and 100. C squared equals a squared plus b squared minus 2ab cosine C. Oh, I forgot to write that too, but it's fine. C is going to be the square root of 100 squared plus 200 squared minus 200 times 100 times 2 cosine 160. And plugging that into the calculator, what you should get is 295.952 miles. Alright, now it's time for some practice of law of sines. So for question 1, we're going to have triangle ABC. Angle A will have a measure of 43.1 degrees and a side length of 186.2. Angle B is unknown, same with angle C. But angle B will have a side length of 248.6. And here I'm just labeling what we need to find. So what we're going to do is we're going to do sine A over A equals sine B over B. This is law of sines. You should know this. Watch Hart's video if you don't. And you should get that sine 43.1 over 186.2 should be equal to sine B, whatever that is, over 248.6. Now, solving for sine B, you can do this however you want. You can cross multiply, whatever. You get that sine B equals 248.6 times sine 43.1 over 186.2. And now, it cut out here. But basically, sine B, the inverse of sine B. Oh, here I am just rewriting it. Okay, that makes it a lot easier. So B is going to be the inverse of sine 248.6 times sine 43.1 over 186.2. And you put this in your calculator, you should get that B equals 65.819 degrees. Now we can use this information that we just learned to find angle C immediately, because we know that a triangle adds up to 180 degrees. So angle C would just be 71.081, 180 minus A minus B. Now we do sine A over A, law of sines again, to find missing side length C. Sine A over A equals sine C over C. And we should get that C equals 186.2 times sine 71.081 divided by sine 43.1. We plug that into the calculator, we get C equals 257.79. Alright, so for this question, we have two forest rangers at two separate towers. The first ranger is 6 miles due west of the second ranger, so make sure you don't mix up ranger 1 and 2. That'll get you the wrong answer. They both spot a fire off in the distance, right? And ranger 1 spots it at a bearing of north 35 east, and ranger 2 spots it at a bearing of north 42 west. We can see that this forms a triangle between the 3 points of interest, right? R1, R2, and F, which is a fire. And we should be able to tell that R1 is 55 and R2 is 48. You just do 90 minus the other two angles. Now what we can do is we can find the angle of the fire, right? It's just going to be 180 minus R1 minus R2. And that'll get you that the angle of the fire is 77 degrees. Now all we do is law of sines. So we get sine F over F equals sine big R2 over little R2. So that would be sine 77 over 6. Sorry, it kind of cuts out here. Which is equal 77 over 6, which is equal to sine 48 over little r2. Solving for r2, we get that r2 is 4.576 miles.